1 again. So again, this is section 5.1. And this section, we talk about the exponential functions. So here they say we should solve the problems from 1 to 4. And I decided to solve only one question. Again, this question straight from the textbook, chapter 1, section 1, exercise. Problems from 1 to 4 said we should use a calculator to evaluate each expression. And these expressions are exponential expressions. So again, they are very straightforward. So I use only one question. Here we have 10 to the power 0.5. Now, most calculators, as we said earlier, there's a key y to the power x. Some calculators use s to the power y, but I think majority of the calculators use y to the power x. So to use the calculator to find any exponential expression or value, example here, 10 to the power 0.5, the first thing we are going to enter the base, the 10. We enter the 10 in our calculator, or if you are using the calculator in the computer, the same thing in the calculator. Then we enter the key y to the power x, if that's what you have. Or if you have s to the power y, you enter that key. Or I would say you press the key. Then 0.5. Then you press the equal, and that should give you the answer. So again, problem from 1 to 4, basically teaching us how to use our calculator to evaluate exponential values or expressions. So example, if I have 10 to the power 20, and I don't want to multiply 10 times 10 times 10 20 times, and that's too long. So the best way to solve this, I will enter 10 first, then I'll press the key y to the power x, if that's what you have in your calculator, or s to the power y, if that's what you have in your calculator. Then after that, we enter 0.5, then we press the equal, and that will give us the answer. So I only chose one question out of the 4 questions in the textbook because the steps are the same. Now, with the next question, we had said we should solve the problems from 5 to 16. We need to graph each of the functions. I decided to do only 5 and 6. We have up to 16, 5 to 16, which are around like 10 or 11 questions. So the question 5, we have y equal to 4 to the power x. So this means I can look for any interval of x, let's say from -2 to +2. So when x is -2, y will be 4 to the power -2. When s is -1, y will be 4 to the power -1, which will be 1/4. When s is 0, y will be 4 to the power 0, which is 1. When s is 1, y will be 4. When s is 2, it will be 4 to the power 2, which will give us 16. So when we get our table with the s and y value, we can plot again our graph. Also, we can use the calculator if we want to. Now, the same thing applies to question number 6. So we can pick any interval, let's say from -2 to +2. So when s is -2, y will give me 8 to the power -2. When s is -1, y will give me 8 to the power -1. Then we get our table, then we just plot it. Now, in the next question, this is application problem. It's about finding the compound interest. So here again, if $1,000 is invested for X years at 8% compounded quarterly, the future value that will result is given to us as a model. S equal to 1,000 times 1.02 to the power 4x. What amount will result in 8 years? So this is, again, compounded quarterly. That's why the exponent is 4 times the x. And again, in chapter 6, we're going to talk about finance mathematics. where we'll learn how to find again compounded interest, simple interest, etc. So here, anywhere we see the x, we substitute with 8. So here we have 1,000 times 1.024 times 8. So we use our, again, calculator and do the expression. So 1.02, then we press the ky to the power x, if that's what you have on your calculator, or s to the power y, if that's what you have. Then we know 4 times 8 is 32, so we enter 32. Then we press multiplication or times 1,000. Press the equal sign and you get your result. So our future value will be $1,884.54. Now, question number 4, so it's a application problem, our textbook, question 33. So here also the model is given to us. And the question said the percent concentration Y of a certain drug in the bloodstream at any time t in minutes is given by the following equation. Y equal to 100, 1 minus e to the power negative 0.462 t. Now here they say we should graph this equation and t should be a value from 0 to 10. So our t interval will be 0 to 10. So here we are going to plot when t equal to 0, what will be the value of y? When t equal to 1, what will be the value of y? Up to 10. So then when we get it, again, we plot those points. And our graph will look in the more or less, as we can see that this is again a log function. Now let's see the 5.2 section. Here again, we pick our textbook, the problems from 1 to 4. Here they say we should use the definition of log functions to rewrite each equation in exponential form. So for example, they gave us a log function 4 equal to log base 216. We need to convert it to, again, exponential function. So we should remember that we set the base 2 to the result 4. The 4 will be the exponent equal to 16. So the answer here will be 2 to the power 4 equal to 16. Same thing applied to question number 2. 3 to the power 4 equal to 81. Then 4 to the power half equal to 2. Then the base is 3 again, 3 to the power negative 2 equal to 1/9. And this is the solution here. So they gave us the formula again. A to the power y equal to x is the same as writing y equal to log base ax. So again, this a becomes the base for exponential, and the answer y is the exponent equal to the x. So 4 equal to log base to 16 means we're going to get 16 equal to 2 to the, again, the base, log base 2. So 2 will be the base to the power 4. Or we can say 2 to the power 4 equal to 16, or 16 equal to 2 to the power 4. So the same thing applied to the second one, 3 to the power 4 equal to 18. Because again, we have log base 3, 81 equal to 4. Log base 3, 81 equal to 4. So the answer will be 3 to the power 4 equal to 81. Then let's see the next question. Here they say the problem from 5 to 14, we're going to solve for the x by writing the equation in exponential form. So we have, again, here we decided to choose the first 10 questions. So let's look at the question number 5. We have log base 3 s equal to 4. Now to solve this problem, we consider the quicker way is to convert the expression to exponential function or equation. Because if I have log base 3s equal to 4, again, the base is 3 to the power 4 equal to x. So s equal to 3 to the power 4, which will give me 81. And here we can see in 6 also the same thing. The answer is log base 4x. So our answer will be s equal to 4 to the power negative 2, which is given here. So s equal to, the base is 4, and the value here is negative 2. So 4 to the power negative 2, which will give us 116. Now, question 7, we have log base 16x equal to negative half. So 16 to the power negative half equal to x. Or we say s equal to 16 to the power negative half. And solving this problem, we will get 1/4. Now with 8, we have log base 25x equal to half. So our base will be 25 to the power half equal to x. And 25 to the power half is like square root of 25. The answer will be 5. Now the next one, we have log base 7, 3s plus 7 equal to 2. So again, the base is 7. So 7 to the power 2 equal to 3s plus 1. So we can solve this equation. We get 3x, 1 will go to the right side. So we get 49 minus 1. S3 is multiplying x. So when it crosses the equal sign, it's going to divide. And our final solution will be s equal to 16. Question number 10, we have log base 3, 7 minus x equal to 3. And the same thing, so the base is 3, so it will be 3 to the power 3 equal to 7 minus x. And that will give us 27. 7 is positive. When it crosses the equal sign, it becomes negative. And we have minus x equal to 20. So we multiply the whole equation by negative 1. And the final solution will be x equal to negative 20. Now, the next question is problems from 15 to 18, but we chose only 2 questions, and this will be the final example here. So our first question says we should write the equation in log form. So the equation is given exponential form. We need to change it to log form. So here again, we know already the 2 here will be the base of the log. And also the 30 here, 32 will be the value. So this means the answer here will be log base 2, 32 equal to the exponent here 5. So we can see the answer here, 2 to the power 5 equal to 32. And we say y is 5, a will be 2, s will be 32. So a is our base. It's like writing y equal to log base ax. So we get log base 2, 32 equal to 5. Now 5 to the power 3, 125, the same thing. We get log base 3, 125 equal to 3. I mean, log base 5. The 5 here is our base. So it will be log base 5, 125 equal to 3. Then we have another 2 more questions. The problem given, this problem is from the textbook again, 19 to 20. They say we should write equations in a log form. So the opposite way now. This is exponential, and we need to again change it to log form. So again, the base is e, so it will be natural log. So we can say the natural log 0.55 equal to 3s plus 5. Then we can solve for x. So 3s will give us natural log 0.55 minus 5, because plus 5 plus the equal sign. 3 is multiplied by x, so we're going to divide by 3. And the same thing applies to the second. We have 10 to the power 2s plus 1 equal to 0.25. So this will be log base 10, or log in general. So 10 is the base. So we get log base 10, 0.25 equal to 2s plus 1. So that's here, 2s equal to log base 10, 0.25. 2s plus 1, 1 is positive, cross the equal sign, become negative. 2 is multiplied by x, cross the equal sign is going to divide. Then we can use our calculator to find the log base 10.25. The answer we get, we subtract 1 from it, then we divide it by 2, and then our final answer will be negative 0.801. So that will be the conclusion for today's lectures, and I hope these examples may help us understand section 5.1 and also 5.2. And hopefully on Monday, we start 5.3, which will be the final section for chapter 5. Then we move back to chapter 4. Chapter 4, we still have 4.3, 4.4 to solve. Then after that, we look at chapter 6. Hopefully that will be our last chapter for the semester. So if no question, again, thank you for your time and see you on Monday.